Today we're doing section 2.2, day 4, and again we're going to talk about those maximizing and minimizing type problems. So for the first example, it says you have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So I recommend drawing a picture. Okay, so I don't know the dimensions, so I'm just going to put an X and Y. So what they do tell us is that we have 100 yards of fencing, so I know that the perimeter is going to be equal to 100. So as far as an equation that we can write, step 1 is what are we maximizing? So we're maximizing the area, and then write an equation based on the conditions. So perimeter means the distance around, so I know I have 2x plus 2y, and that's equal to 100. And now from here we solve for y, so we'll subtract the 2x over. So I'm left with 2y equals negative 2x plus 100. We're going to divide everything by 2. So y equals negative x plus 50. Now that I have this equation for y, I'm going to come over to what we are maximizing. And I should probably actually come down here so I have more room. We have x times y, and I can replace y with what it's equal to, which is negative x plus 50. I distribute that in, I'll get negative x squared plus 50x. And now that I have this equation, we're going to find the vertex. So I'm going to do negative b, which is negative 50, over 2 times a. So I have negative 50 over negative 2. So my x value is 25. And once I have x value, I'm going to plug it into here to find the y value. So I have y equals negative, and I plug in the 25 plus 50. So I get y equals positive 25. But again, the directions want to know what is the maximum area of this rectangular region that is enclosed. So 25 times 25 gives me 625. And it was yards. We're talking about area, so it is yards squared. So again, if there's units given, I expect you to put units on your problem. So let's go ahead and try one more. So we have 2 more to do. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and the width of the plot that will maximize the area. What is the largest area that can be enclosed? So over here on your copy and my video, there's this really terrible video, a picture of a little fenced-in area, and we're assuming that this is our water. So we're going to call this side x, x, and then this third side y. Now let's say you thought y, and x. That's fine. You would still get the same final answer. It was just our x and y values would be flip-flopped, and that's totally fine. So what we're trying to maximize is area. So based on this picture, the area would be x times y. Based on the given conditions, I know 2x plus y is going to be equal to 200 because that represents our perimeter. We're going to subtract the 2x over, so I have y equals negative 2x plus 200. Now that I have that, I'm going to put it into this equation here. So y gets replaced with negative 2x plus 200. And we're going to distribute. So I get negative 2x squared plus 200x. And then my next step is I have to find the vertex. So to do that, I have x equals negative b, which would be negative 200 over 2a. So I have negative 200 divided by negative 4. So my x value would be 50. Now I plug that into my equation up here. I have y equals negative 2 times 50 plus 200. So this will be negative 100 plus 200. So I know y is equal to 100. And now I find the area, multiplying x times y, and the area of the rectangle region will be 5,000 feet squared. So a lot of times student thinks when we first do these maximizing and minimizing problems that X and Y are always going to be the same because that's what you're exposed to first. Do not always think that the moment we talk about a fence and we're missing sides, your values are going to be different. So let's go through the hardest one you'll see in this section. So this one says a rectangular playground is to be fenced off and divided in two by another fence parallel to one side of the playground. 400 feet of fencing is used. That's important. Find the dimensions of the playground that maximize the enclosed area. So let's just draw a little rectangular region off to the side to give you a visual. So we'll call this side X, we'll call this side Y. One of the sides is fenced off with a third side parallel to the one side. So if I draw it like this, I now have two regions for this playground. So what we're trying to maximize is the area, which will still be X times Y. The perimeter will be different. I'm now going to have 3 X's and 2 Y's. And that's equal to my 400. I need to solve for Y, so I'll subtract the 3X over. So I have 2Y equals negative 3X plus 400. And we divide everything by 2. So Y equals, we'll split this up, negative 3 over 2X plus 200. Now I need to take that and I'm going to plug that into the A equation. So I'm just going to do this over here. So I have X times this negative 3 over 2X plus 200. We'll distribute the X. So I have negative 3 over 2X squared plus 200X squared. Not X squared, just X. Just kidding. All right, so now we need to find the X part of the vertex. So I have negative B. So I have negative 200 over 2A. So over 2 times 3 over 2. So I think it's easier to leave it in fraction form because you can kind of see what's happening here. So the 2's cancel, and I'm left with a 200 over 3. And again, I'm going to leave my X value as a fraction just because when I plug it in, it works out a little bit easier. So when I plug it into the equation, I have negative 3 over 2 times 200 over 3 plus 200. So the 3's are going to cancel. Negative 200 divided by 2 leaves me with negative 100 plus 200. So my Y value is equal to 100. Now, if you want to put this as a decimal, so when I go ahead and multiply, you can. So you would do 200 over 3 times 100, and the area, let me write it up here actually so you can see it. So my area will be equal to 6,670 feet squared. Okay, so if you wanted to know, this 200 over 3 is 66.7. Okay, but obviously we would use the calculator to get those answers. All right, that's all for today.